Let's talk about the structure of an IPv4 address. IP version 4 addresses are 32 bits long. A binary digit, or a bit for short, its basic unit of information in computing. It is the amount of information stored by a digital device or other physical system that exists in one of two possible distinct states, such as on and off, or ones and zeros, or true and false. An example of all ones and all zeros is right here, all ones and all zeros. You may be familiar with the usual IP dotted decimal notation representation, such as 192.168.24.220, that corresponds to the binary numbers below, the four octets. The 192 corresponds to the first 8 numbers in binary notation, and these would be 168, and that's 24, and the last octet, it's 220 in binary. It's noteworthy to mention that dotted decimal notation is only used to make it easy for us to remember, because the computers use the binary system, which happens to correspond exactly with the on and off states of electricity. In this example, we can see an IP address of 131.107.16.200 divided into the network part of 131.107 and the host ID of 16.200. As you can see, the 32 bits have been divided in half. 2 octets are for the network and the other 2 for the host. If this was all there was to it about IP addresses, it would be really simple. You would know that half of it is for the network ID and the other half is for the host. But the tricky thing is that each of the parts could be different sizes. It doesn't work that all the time half is for the network ID and the other half is for the host. Now the question is, how do you determine which part of the 32 bits is used for the network ID and which part is used for the host? That is where the network mask comes in. Okay, let's look at the IP address I first used. We use a subnet mask to determine which part of the 32-bit IPv4 address is a network ID. In the first IP address example I used, the 192.168.24.220, I did not tell you which part of it was the network ID and which part was the host ID. If I had written the same IP address as 192.168.24.220/24, then that would have included all the information needed to determine the network ID and the host ID part. The /24 indicates that the first 24 bits of the total 32 in the address are the subnet masks. Let's look at the IP address right here. This is the same IP address, and the subnet mask is 255.255.255.0. Now let's look at the same address right below it in binary format. The first part of it, it's the actual address, and the subnet mask is composed by the first 24 bits set to 1 to indicate that that is the network ID part, hence the /24. Okay, going back to the second example that I used in this tutorial. Looking at this example, we can see that the IP version 4 address of 131.107.16.200 was divided into exactly half. The first 2 numbers correspond to the network ID 131.107, and the host ID is the 16.200 part of the entire IP version 4 address. The 32 bits, as you can see here, have been divided exactly in half. 2 octets for the network and the other 2 for the host. Then this IP address can be represented as 131.107.16.200/16. As you can see right here. Now the 16 means that the first two octets, these ones right here, it's 8 of them, the first and another 8 here, are 16, and that these guys are set to 1 and represent the network ID part of the address. Now, in binary, all these numbers being set to 1 translate to decimal 255. Then this would be, in decimal dotted notation, would be 255.255.0.0. That would be the network mask in this scenario. Now, the two subnet masks I used in the previous examples, one of /24 and the other one is /16, are relatively easy to interpret because they are divisible by 8. As we can see in this example, it's a /24, so we are using for the network ID the first 3 octets, and in the other example it's a /16, and so we are using the first 2 octets. But what about if instead of being /16 was a /17 and this number we made into a 1 to denote that it is also part of the network ID? As you can see by this last example I just mentioned, subnet masks are not always divisible by 8, and then they're always not so easy to interpret, as we shall see. Okay, in dotted decimal notation, the subnet mask takes the form of a 32-bit IP address. In other words, it looks just like an IP address. So if we're looking at /8 address in decimal dotted decimal notation, that would be 255.0.0.0, and for /16 address, that would be 255.255.0.0, and for /24 address, that would be 255.255.255.0. I think I should mention this because it's important. Occasionally you may hear that a /8 address is called a class A address, and a /16 is a class B address, and a /24 is a class C address. However, this was used in an older system of IP routing, and it's pretty much obsolete nowadays. But just know that if you hear class A, class B, and class C, this is what people would be talking about. The slash notation, slash notation is known as classless interdomain routing, or CIDR. Okay, so the subnet masks that we have been looking at in dotted decimal notation have octets whose values are represented as either 255 or zeros. Now, this limits the discussion to only 3 possible subnet masks, the ones represented here, and formerly known as Class A, Class B, and Class C. However, in our discussion we said that the slash notation, such as /8, /16, and /24, is the classless interdomain routing notation. Now, these are in fact the most common subnet masks that you will encounter, and especially slash 24, which is one of the most commonly used subnet masks.